Capacitors in circuits 1. Use any of these equations to determine the various quantities for the circuits shown. You can see we've got the equation for capacitors in parallel, which I've called the atom-up equation, the equation for capacitors in series, which I call the 1/over equation, and then we met this equation when we were dealing with capacitor plates. There's the definition of capacitance in a couple of different ways, and here's a number of equations, any of which you can use to find the energy. So let's see what we got here. The equivalent capacitance of this circuit, these two are in series. If I wanted to tear those out and put an imaginary one in there, I would have to go 1/12 plus 1/6, add those up, and then take the inverse. 1/12, and then this is 1/6 would be 2/12. So that'd be 3/12 flipped upside down. So I think the equivalent capacitance is going to be 4 microfarads. The total amount of charge that moves in a circuit is equal to the equivalent capacitance times the voltage of the battery. That comes from the equation, let me scoot up here, right there, top left corner, right there. Capacitance is Q over V. The total amount of charge that moves in a circuit is equal to the equivalent capacitance, that is the capacitance, you might say, that the battery perceives times the voltage of the battery. So that's going to be 4 times 9, so that's going to be 36 microcoulombs. That micro prefix hangs around. Whenever we have capacitors in series, the charge is the same. So this one is going to be 36 microcoulombs. On capacitor 1, 36 microcoulombs. That's the charge on capacitor 2. Now, what about the voltage across capacitor 1 and 2? Now, the voltages aren't equal for capacitors in series. The charge is, but the voltage isn't. So what we'll do is, let me scoot up one more time. There we go, that equation that I circled at the top. You see, if we rearrange that, it's going to be Q over C. So V1 is Q1 over C1. Q1 is 36, C1 is 12, 3 volts. Same idea here. Q2 over C2. Q2 is 36 divided by 6, 6. And you see how nicely that adds up to the 9 volts of our battery. Whenever we calculate the energy, we can use, you can see them in the upper right corner there, any number of equations. If possible, I like to use this one here on the right because it doesn't have any squared terms, so that makes things a little bit easier. And since we have the charge and the voltage for all of these, this should be pretty easy to do, I think. So this is going to be 1/2 times 36, so that's 18 times 3, 54. 54, and then we have a prefix of micro in there, and the unit would be joules. Same idea here for the energy stored in capacitor number 2. The charge is the same, the voltage is twice, so that should be 108. Now, the total energy is just going to be the sum of these, but another way you can find total energy is to take 1/2 times the total Q times the voltage of the battery. And if you do that, that's going to be 1/2 times 36, so that's going to be 18, times 9, which is going to be 162. What does this come out to if you add these up? 162. Look at that. Let's do one more. These capacitors are in parallel, so the equivalent capacitance is merely going to be the sum of these, which will be 18 microfarads. The total amount of charge, again, from the equation, I'm going to go ahead and write it over here because it's such an important equation. The total amount of charge in any circuit is going to be the equivalent capacitance times the voltage of the battery. So in this case, that's going to be 18 times 9, which is 162. The micro prefix is still hanging around, so it's going to be microcoulombs. All right, the charge for capacitors 1 and 2 is not going to be 162 each. What will be the same is that the voltage across these capacitors will be the same as the voltage across the battery. You can see in what I've drawn here. The difference in voltage between red and green is 9 volts. Therefore, the voltage across capacitor 1 and capacitor 2 is also 9 volts. What does that mean? Q1, according to this equation, Q1 is going to be C1 times V1. C1 times V1. C1 is 12. V1 is 9. 12 times 9, 108 microcoulombs. C2, V2. 6 times 9, 54 microcoulombs. What about the energy stored? Any number of equations you can use for that. I'm going to use that. And we do that one in our head. 1/2 times Q1. So that's going to be 54 times V1. So that would be 540, 486 microjoules. You check and make sure. 1/2 Q2 V2. So that's going to be 27 times 9, which would be half of that. So that'd be 243. The total energy should be the sum of these, but let's check another way. Let's see if the total energy is equal to 1/2 the total charge times the voltage of the battery. 1/2 of the total charge is going to be 81. 81 times 9. So that's going to be 810, 729. 729. What do these add up to? Look at that. All right. That's kind of how you do those problems.